In this JavaScript tutorial, you're going to learn everything you need to get started programming in JavaScript. If you want to learn JavaScript for web development, machine learning, backend programming, then it's the perfect place to start. You don't need any prior experience in JavaScript or programming in general. I'm going to teach everything from scratch, from the ground up. My name's James, and I've taught thousands of people how to code through this channel. If that sounds good to you, then smash the subscribe buttons as I upload new videos every week. And with that said, let's get started. Also, just a quick little editor's note. The material presented to you in this YouTube video is part of a bigger JavaScript course that is available on Udemy. I've cut out all the key subsections that you'll need to get up and running and feel comfortable in your code editor and feel confident developing in JavaScript. The link to the Udemy course is available in the description down below. And with that said, let's get back to the tutorial. Just to quickly run over the course curriculum for the YouTube edition of this course, in the first section we're going to start off by setting up our code editor and our environment, which is required for writing and running JavaScript. Then we'll have a quick overview of what JavaScript actually is, how it works, and what it's commonly used for. And then for the remaining majority of the course, we'll cover all of the foundations in JavaScript you can code along so that you feel confident in your JavaScript code editor running and executing all different types of JavaScript. Finally, there is a course companion set of notes, and they will be linked in the description down below. Chapter 1, Setting Up Our Code Environment. It's now time to get set up with our code editor. Now in this chapter, we're going to configure and download everything you'll need to be able to code in JavaScript inside of a code editor and consequently execute your code, which just means to make it run and follow the instructions. Now there's two things that we'll need in this chapter. The first one is VS Code. Now there'll be a link to the download available to you, but equally you're welcome to just come over to Google, and if you type in Visual Studio Code, which is a code editor, it's where we can write our JavaScript code. We're just going to hit the download link, and that's going to redirect us to a page where we can download the Visual Studio Code that's appropriate for our operating system. So if you're coding on Mac, then you'll download the Mac option. If you're coding on Windows, you download the Windows option. And likewise with the Linux operating system as well. I already have it installed on my computer, but just to show you, we would click on the download and we can just save it to a download file. Once it's downloaded, you just want to open and execute that download file, and that should prompt you to complete the installation on your computer. Now, just to quickly show you what Visual Studio Code is, if we open up a new window, you should have the option to on your computer. It's basically just a code interface that we have right here. And the key features about it is that up the top we have an Explorer. In the Explorer we can create a project directory. Now the way that I like to do this is I would hit open for the first time. Inside of here I have a dedicated folder where I have all of my coding projects. You can see them all here, there's a bunch of them. And basically what you want to do, I've labeled mine GitHub 2 because I use GitHub to store my code, but you don't necessarily need to worry about that. All you'll do is you'll create a folder. Within the folder that's going to hold all of your projects, we're going to create a new folder, and this one's going to be called the Complete JavaScript Course. Now I've already initialized my folder, but this is where we're going to be doing everything inside of this project. You'll just want to create this folder. It can be empty on the inside for now. And once you've created that folder, you'll then want to hit open on that selection, and that will go ahead and open up that project directory for you. Now we know that we're in the correct project folder because it shows up here, the Complete JavaScript Course. And I can see I have some subfolders and some files in here as well. Now just to demonstrate how we are going to use this, essentially what we'll do is if I wanted to create a new JavaScript file, all we do is we click the folder or in the white space here, or using these little navigation tools at the top. This is the create file, this is the create folder. I'm going to create one inside of notes. I'd recommend you also create a folder called notes, new folder. And inside of notes, we're going to create a new file, and I'm going to call it chapter 1. Now that's not quite it. If we save the file just with this name, it's going to be a plain text file, and that's not going to be able to interpret our JavaScript code. So what we do is we add an extension, a file extension, which is a suffix to the folder. And to create a JavaScript file, all we do is we use the .js to create that JavaScript file. So this will create a JavaScript file called chapter 1. And inside of Visual Studio Code, we can see that the JS shows up, so it recognizes the file extension for us. Now, if I hit enter, that's going to open up our file inside the actual editor. Here we can see the number of lines that our file has and we could go ahead and save that. Now, the files can be whatever you want. In the guide, it suggested that you could name your files index.js. That's what you would name them if you're going to have one primary file inside of your folder, but otherwise you can be more explicit and specific with the names. Now, with our JavaScript file created, the next thing we're going to have to install is NodeJS. And in this chapter, we're just going to cover how to install it on our device. We'll go into what it actually is in depth a bit later in the course. But for now, it's basically just a runtime that can be used to execute and interpret our JavaScript files. So how we're going to install it, you could follow the installation guide that is in the course notes, or you could come over to Google and just type in Node.js download on Google. This will also be linked in the course description, and we can just come up to this download link right here. And once again, you'll just choose your operating system. So I'm on Mac. If you just click on your operating system, you'd want to go for the latest version. That will prompt you for a download, and once you've downloaded, if you just execute that, it will install Node.js on your device. Now, for Node.js, there is a way to test if it's installed correctly on your device. And to do that, what we'll do is we'll come back to our programming interface, and we're going to learn something new about Visual Studio Code. And it's essentially that inside of VSCode, we can have what's known as a terminal. But if you just Google how to open VSCode terminal into Google, you can see there's plenty of instructions, and there's also a shorthand, Control-Shift-P. And so in here, we can use that command, and we can go toggle terminal, hit toggle terminal, and that's going to open up a terminal for us. Now, in addition to using Control-Shift-P to open up our terminal, you should also be able to come to your file options, either on Mac, which is along the top of your window, or on Windows along the top of your file, and come over to terminal and hit new terminal, as you can see on the screen, or you can use the command Control-Shift-P to then toggle the terminal. Either way is fine. Now we can see that the terminal is open inside of our project directory, and in here we can run commands, terminal commands. And if we've installed Node correctly, we should be able to type Node and then a space and a dash and a V. The V is shorthand for version. And if we hit enter, that will show us the version that is installed on our device. Now, if Node is not successfully installed on your device, this will show up with an error, and it will likely prompt you with the recommended installation methodology for your system. So we've now got Visual Studio Editor created. We have created a JavaScript file with the .js extension. We've got a bunch of empty lines in here. We've learned how to open a terminal, and we have installed Node.js on our device. That is absolutely everything you'll need for the rest of this course to run everything, write all of our code, and execute it. And we'll be working within Visual Studio Code a lot, because the sooner you can get coding, the better it will be for your long-term knowledge. Chapter 1.2, Overview of JavaScript. It's time to jump into chapter 2, and this is where the magic will start happening. So this chapter is going to be learn basic JavaScript syntax and concepts, and we've got a fair bit to go through. We'll start off by first doing an introduction to JavaScript, how it works, what it is, and what it's used for. Then we'll talk about the fundamental JavaScript syntax, including variables, data types, and operators. Then we'll discuss a bit about control flow through conditional statements like if blocks and for loops and while loops. And then we'll touch on some functions and their use in structuring code. Now, to start off with the introduction to JavaScript and how it works, the way that I like to think about programming, either in JavaScript or any other programming language, is as if I were writing a set of instructions. Now, one of the most common examples of writing out instructions is a recipe or a recipe book, where you order the steps that someone needs to follow in order to craft and cook a recipe. If you miss a step or don't explain something, the user or the individual trying to cook your recipe will probably break down, and you have to go and debug them. Now, we can think of programming and scripting as writing out a set of instructions, except instead of writing them out for a human to interpret, we write them out so that they can be interpreted by a computer or a machine. The machine can go and follow the instructions, and instead of producing a fresh batch of cookies, they might have a machine learning output or a web application, as we earlier discussed. Now, obviously, we write recipes out in the English language or whatever language it is that you speak, and each language has different rules, and programming is exactly the same. Essentially, every programming language has its own unique syntax, which is how we write out the instructions. The syntax can then be interpreted and run on our machines, and the machine can go and follow all of the instructions. The place that we write all these instructions is inside of a script or a code file in a code editor. And the instructions will, for the most part, go from top downwards to the bottom. Now, the other thing that's kind of interesting to know, it's not essential by any means, it's just for your general information, is that there's different levels of programming languages. So in one instance, we have low-level languages such as assembly code or machine code. And at the other end of the spectrum, we have high-level languages like JavaScript and Python. Now, the way that makes sense for me to differentiate the two of them is high-level languages are closer to being readable by humans. So the syntax is created so that when you and I look at some JavaScript code, we can pretty quickly get the gist of what's going on. So it's very human-centric, whereas a low-level language is much closer to being the language spoken by the computer, which is ultimately binary. It comes down to just zeros and ones, and that's because of the fundamental nature of hardware, where we have a transistor. It's the core unit of a computer, and a transistor can occupy either an on or off state, and then if we combine millions of transistors, we're left with a CPU, which is the central processing unit in a computer, which is the part of the computer that will execute all of our code. So the moral of the story is that JavaScript is created to be closer to the human language side than the machine language side, and consequently we refer to it as a high-level language as opposed to a low-level language like machine code, which is going to be almost entirely unintelligible for most people to read through and understand. Now, as for how we write and run JavaScript files, just coding out JavaScript inside of a JavaScript file is not actually going to do anything. We write out this set of instructions inside of our code editor, but then we have to go and actually get the computer to execute the file. Now, to do this with JavaScript, we use what's known as a runtime, and that's exactly what we downloaded earlier. NodeJS is a JavaScript runtime, and the runtime understands how to interpret the JavaScript code, which is then executed on our machine. So the runtime is essentially the body that listens to the instructions and then utilizes the machine to go and actually execute them. Now, machines can either be cloud or local. A local device is the one that you'll likely be programming on. Equally, we can connect to a cloud instance or a cloud machine and execute our code there later. And that's something we'll also touch on later in the course. Anywho, that's just a very brief overview to the realm of JavaScript. The main takeaways being that JavaScript is a set of instructions where we have to be pretty explicit so that the machine can interpret them, and we write them in a JavaScript file inside of a code editor, and then we execute them using a runtime such as Node.js, and the runtime then interprets the code and translates it into an output. Chapter 1.3, Coding in JavaScript. Now that we've got a bit of a foundation to JavaScript, what it is, how it works, the next thing we're going to do is jump into our code editor and look at some of the basic beginner syntax that you need to be familiar with to start writing your JavaScript programs. To do that, we're going to swap back over to our code editor. Here we have it set up just as we did before. We've got the notes folder, and in here we have chapter 1. Technically, this should actually be chapter 2, so I'm going to rename this file chapter 2, just like that. Now I'm going to keep my terminal open, however I'm going to minimize it on the side just here. And the first thing we're actually going to do is delete a bunch of these lines just here, just one line at the top, and I'm just going to type something random. So I'm going to type hello world, because conventionally that's the first thing that a new programmer does in every single language. Now, as soon as I type that out, we can see we have a red underline, and inside of JavaScript, a red underline means that you have a syntax error and you've made a mistake. This code will not run correctly. Now, the reason this isn't working is because JavaScript, like any language, has a bunch of rules that we have to follow, and we have already broken a rule. In this instance, we're trying to write out a sentence that for us in English makes sense, but to the JavaScript interpreter that doesn't make any sense at all. It's just a series of characters that have a different meaning to it than us. In JavaScript, if we wanted to write out a sentence or a bunch of words using different characters, we have to use what's known as a string. Now, a string is a data type that is used for a string of characters. And the way that we create a string in JavaScript is we wrap our series of characters in either single or double quotes. Now you can see if I save that, the red line has gone away, and this is now something that JavaScript can interpret. it's like, oh, this is a string. I know that this isn't meant to be anything programming related. This person just wants to write a sentence in this programming language. Now that's all well and good, but it actually doesn't mean anything in the context of writing JavaScript. We've just successfully implemented a string. And where there is a string as a data type, there are a whole lot of data types. For example, we can put numbers in. Note how if I go into a new line, we don't get any errors, so that's safe. And there's a bunch more that we will touch on shortly. Now, our first goal in the language is actually to get the language to print this world. And the way that we can run a script or a series of JavaScript instructions that are contained within the script is we can come into our terminal and we use the node runtime to execute our script. So what we would do in here is we would type node, and you'd think we would type the name of the file, chapter2.js. However, that's going to give us a big bad error. And there's two reasons we're going to get the error. The first thing is the naming of your files is best if it doesn't have any spaces. The typical convention to replace a space is with an underscore. So we're going to rename the file with an underscore between the chapter and the two. But if we now reattempt to execute our file using the node command, and we pass in the name of the file that we want it to execute, so that's chapter_2.javascript or .js, and we execute it, it still can't find the file. And the error, this is an error log, which basically is the node runtime telling us what happened. It said it can't find the module, and here it's saying it can't find the module at this particular path. Now, the JavaScript course, that's the name of the folder that we're working in, and then it's looking directly within that folder for a chapter 2. However, we actually have our chapter 2 file contained within a notes folder. So instead, all we have to do is make sure that we pass in the subfolder directory and then the name of the file. So it's going to be notes slash, where slash denotes, okay, this is contained within, enter that new folder, chapter2.js. And then if I hit enter on that, we can see that that now executed our file. Now, as much as it may have run our file, we didn't get any errors. We note that we didn't get any terminal output. In the context of JavaScript, this is also known as the console, and you'll notice in a lot of development applications they say go to console. It's kind of the programming interface of where everything is happening, where you can run commands. And so if we want to print our string, our sequence of characters, our string of characters to the console, we can use in JavaScript what's known as the console class. We type console and then we use the dot or a period, and we access what's known as a method within that class. And we'll talk more about what this means later. We're just going to, for the second, cover the Console.log. But all you really need to know is that we're saying, okay, get the console, and then to the console we want to log it, and then we use the circular parentheses to pass in what's known as an argument. Once again, this will all be explained further on. However, the Console.log is going to be incredibly useful as we progress throughout this course, because it's the #1 way to debug your code and understand what's going on. Now, at this point, I should mention, when we make changes to our code file, it's important that we save the file before we re-execute it, and we can save it using Command S. And we can see that there is a change to be saved in this file because of the white dot. When I save the file, that goes away, and now the file is ready to be re-executed. And every time we wish to re-execute a file, we come down to our terminal and we need to retype out the node command. So now we've got the Console.log. If we try to run that again, we can see we actually got something different than the first time. We got an empty line. And that's because we didn't pass anything in as an argument to the Console.log. So if we now copy our string, let's say we copy our string, we have the circular parentheses, and we paste our string inside of it. Now what we would expect to happen is we would say, okay, get the console, we want to log, not logs, just log, and then inside of the circular parentheses, we pass in exactly what it is that we want to log. And that is going to be the string data type that contains a sequence of characters, which is hello world. Now what we would expect is basically for this to be printed down here. If we run that file once more, the way that I'm getting the command really quickly in the terminal is I'm just pushing up and down. The up and down arrows will allow you to navigate through previous commands. If I hit enter on that, we can see that our terminal now prints hello world. And congratulations, that is the first step to becoming a programmer. You have completed the initiation. So we'll be seeing Console.log a whole lot throughout our journey, and it's absolutely brilliant for finding errors in your programming because it's basically telling the JavaScript runtime to spit out some information and see what it's actually saying. So with that all done, we can take a look at what else we can do with Console.log. We can also console.log numbers. So if I console.log 4, it outputs 4 just here. And we could also do operations, so I could say 4 plus 4 as if it was a calculator. And now we would expect to see 8. Interesting thing about this is the order of execution. This was evaluated before the console.log. Now if we come back to the string just before, let's say I wanted to type hi mom, we all know that this is not acceptable because if we want to write a sentence in JavaScript, we need to wrap it inside of the quotation marks. Now it's safe. The next interesting thing is, let's say for example, we wanted to say his and then have another apostrophe. We see that breaks our string, we get the red underline, and if I try to run this code, it's not going to be happy. So one good thing to note is that if you want to have an apostrophe within a string, just use the opposite type of apostrophe. So if we use the single quotation marks and say, hi mom, I can use the double quotation mark within and vice versa. That's acceptable. So now, likewise, if I console.log this, we can see that literally will output down below. There we can get that double quotation mark coming out. The next thing we can do that's super cool is use variables. So when we come back to our string just here, we type hi mom, and at this point I'd recommend you kind of coding along and experimenting with all of this. This is currently existing as what I would call a value. The value in this case is a string that says hi mom. Now what we can add to the mixture to make it a bit more interesting is what's known as a variable. So let's say I wanted to call this a sentence. So let's say I wanted to label this as my sentence. I could say my sentence is equal to hi mum. The equal is what's known as the assignment operator. It's basically assigning this string to this variable. Another example could be, number of eggs is equal to 3. 3 is the value and number of eggs is the variable. Variables just help to make our code extra clean, and the other benefit of variables is that they allow us to reuse the value later on and just refer to it by its variable. There's a couple interesting things going on here that we need to take a note of. The first one is in the variable name, there's a few rules that come into naming variables. The first one is that you can't start your variable name with a number. And the second one is that you can't have spaces in the name of your variables. We can see just doing that made our code extremely unhappy. So if we go back to how we had it, one way that we can kind of add spaces to our code is using what's known as snake case. Now snake case is equivalent to what we did in naming this file. Instead of using the traditional space, we just use an underscore instead. And that just means that we can refer to number of eggs as a whole. The other option is what's known as camel case, where the first word starts off lowercase. However, every word thereafter starts off with a capital letter. And it's named camel case kind of in the same way that camels have humps, so every new word is a hump that starts off with a capital letter. For this tutorial, we'll mostly be using snake case, but you can use one or the other. However, it's best practice if you stick with one and are consistent with one. Try them both, but in different instances. Otherwise, it can be confusing because you forget which one you used. Now, we're not quite done yet. Both of these at the minute, if I try to, let's say, for example, console.log, and instead of passing in the strings directly, I could actually say console.log sentence. Now, what this does is it says, okay, find sentence. Let's imagine sentence is a box, and inside the box, it contains hi mum, and the box is labeled with sentence. So find the box, find what's inside, and log it to our console. If I go ahead and run this, we can see that it does actually work. Instead of console.logging sentence, we actually console.log the value associated with the variable sentence. However, we've done one naughty thing. We haven't initialized our variables properly. Now, this would be appropriate syntax if somewhere else we had already initialized our variables, but the first time you use a new variable, you have to initialize it using one of 3 keywords, where one of them is kind of irrelevant. So the 3 keywords that we use are var, let, and const. Now they all do something different. Var is one that we're not really going to use. We're predominantly going to be using let and const because that is a more modern syntax. We use constant or const to initialize a variable when the value associated with that variable is never going to change. We can guarantee that it's going to be constant forever. So let's say I wanted the sentence to be permanent forever. I would just use const sentence. And since number of eggs also hasn't been initialized before, this could vary depending on how many eggs you like to eat, so I'm going to use let to initialize this variable. If we run this code again, we should get the exact same output. However, now we've just initialized our variables correctly. Now, one thing to note is that if you've already initialized a variable once, you cannot initialize it twice. That's just going to make your syntax unhappy. Variables have to be initialized once only, and that name becomes unique. Once again, in some cases, if you use the let keyword, you can reassign a new value after the initialization of the variable. So here what I could do is I could say, let's say I've eaten more eggs this week, I could say let number of eggs equal to 8. My code is happy. If I run it, we still print hi mum because that's the sentence that we're printing. But now if we instead print or console.log number of eggs, we would expect, well actually here's a question. Do you reckon we'd expect 3 or 8 to output? If we check it, we can see that 8 outputs, and that's because we reassigned a new value to the variable number of eggs. If I, on the other hand, tried to say sentence is equal to hi dad and run this code, we get an error because we tried to assign to a constant variable. It's very unhappy. However, if I change the declaration to a let, we now know that we can reassign a new value to the variable, and we could go ahead and run that, and we output 3. The sentence has been reassigned, and if we were to actually print that sentence, likewise we would expect it to be the new sentence. So it says hi dad. So that's all happy days. Now there's one more syntax that we can use that's pretty clever. At the very top just here, when we initialize a variable and we use a declaration, we actually don't have to immediately assign a value to it. So we could say let sentence, and then on a new line we could say let number of eggs, and then we could remove the declarations just down here, like so. And that's also going to be happy. As long as we've initialized our variable using a declaration, then it's all good. No worries at all. Likewise, if you have a bunch of them, you can actually comma separate them and put them on the same line, and that will be adequate code too. So that's a whole lot about values and variables. The main takeaway is that you just want to be using the let or const keywords to instantiate your variables when you first use them. And a variable just stores the value for later use in our code. So instead of having to rewrite out hi mum every time we wanted to use the sentence, we could just thereon forwards refer to it as the sentence. The next thing we're quickly just going to touch on is commenting in code, in JavaScript specifically. Commenting is also an invaluable tool in terms of just overall code behavior, debugging skills, and all that kind of stuff. Obviously, our main action in this code base is to define some sentences, some numbers, and then print them out. What we could do is in some lines, let's say we didn't want to now change the sentence and we wanted it to remain hi mum. If we use a double forward slash at the start of the line, that's a code commented line, and our JavaScript runtime will not read it. So now if I go ahead and execute the code, we can see that the sentence is actually just the one it was when we first assigned a value to the variable. Code comments are absolutely brilliant because if you have complexity in your code, you can leave a whole lot of notes, and JavaScript won't read them, but you can personally read them, and so can anyone else looking at your code base. Throughout this course, I would recommend writing absolutely loads of comments all over the place. If you hear something that I say and you think it's interesting, or that you might forget it or you want it later, take a note of it, but likewise the notes are obviously available in the companion guide as well. It's just great practice. Likewise, you can comment out heaps of code by selecting a whole lot of lines and just adding the double forward slash in front of them. Equally, you could use a double forward slash at the end of a line, and still everything thereon afterwards will be commented out as well. The one other funny thing that we can do in here, just before we move on, very last thing is we can actually do an assignment by reference. Now, this is something that's ever so slightly more complicated, but basically what it means is it could be total Let's say we have a variable called total groceries, and we have to remember that we have to instantiate it. I'm going to use let total groceries is equal to, we could also put the value of 3, but in this case, since we're only getting eggs, we could directly assign the number of eggs. Now this is what's known as assignment by reference, and essentially what's going to happen is total groceries is going to be equal to, well actually let's find out. If we quickly copy total groceries, we can paste it inside of our Console.log, and we can now print it to the console, and we can see it's equal to 3. Now if I update this value, let's say number of eggs is equal to 8. What do you reckon total groceries is going to be? Is it going to be the initial value 3? Is it going to be 8? Let's find out. It's now equal to 8. So assignment by reference just says, okay, find whatever value it currently is now, and then assign it to the new variable. The one other interesting thought experiment we can do here, and this is not something I would really worry about, this is just kind of nitty gritty, interesting to know. Let's say we assign total groceries and then we change the value of number of eggs to 10. Do you now reckon it's going to say 3 or 10? Well, let's take a look. We can see that it does say 3, and that just means that it doesn't constantly track the value of number of eggs, it just assumes the value of eggs when we first make that assignment. Now if I just go and get rid of a whole lot of this stuff up here, we'll keep the console.log for the minute. The two data types we've looked at so far are strings and numbers. So a number is obviously, there's a big number, JavaScript is happy, and obviously the string, hello world, that's not happy, but if we wrap it in quotations, now it is happy. The first one is the number data type, so this is a number. And the second one is, this is a string of characters. There are numerous other data types that JavaScript is happy with. The next one is null. Now null is a special keyword in JavaScript where it basically just means the absence of a value. Another one is undefined, and similar, not quite the same. Undefined represents the absence of a value, not because it hasn't been assigned yet, but because we maybe intentionally just want to basically set it equal to nothing. But we'll come across those more shortly. Another one is the Boolean data type. Now Boolean itself, if I type that out, doesn't really do anything. However, the two Boolean values that we can have are true, it's kind of like logic, and false. So in JavaScript we can have statements, they can evaluate to either a truthy statement or a falsy statement, or we can just have the values true or false straight up. And they will come in handy when we start looking at if clauses and all that good stuff later. After Boolean values, so we have true and false, let's just write that out. So let's say true and false. These are Booleans. The next one we're going to look at is an object. Now an object, also commonly known as a dictionary, is a data type that has an opening curly parentheses and a closing curly parentheses. And these are used to store complex data, and essentially where before we kind of looked at how we can have a variable and a value, so we had sentence is equal to hello world, the value is hello world, and the sentence is the variable. Dictionaries instead have key value pairs. Now to understand dictionaries, we can actually use the dictionary as a pretty good analogy. For example, I could have the key James. In a dictionary we have what's known as key value pairs. So in a dictionary the key might be the name of a word, and the value would be the definition associated with the word. So I could say is super cool. Now furthermore, in a dictionary we can have multiple key value pairs, and each key value pair needs to be comma separated. So I could have Lucy just here, and we could say that Lucy isn't so cool. Notice how in this case I used the apostrophe and it broke our string. So what I could do is either change that to the opposite apostrophe, or I could actually be super clever and use what's known as escaping an apostrophe. So there we use a backslash in front of the variable that we want to escape. So basically JavaScript doesn't interpret it the way that it normally would. And just uses it as a text value. Now our dictionary isn't that happy at the minute. We can see that little red underline, and that's because we haven't assigned it to a variable. So here I could say let friends equal to my now dictionary. Now there's obviously a lot more to dictionaries, but the point is it's just a key value pair. Here I could have number of eggs. assign that equal to 3, the value has to be a valid JavaScript data type, and the name, once again, it cannot have spaces. That's not going to work, so stick with your casing choice. Down here, I could Console.log friends, and if we now go ahead and execute our file, we can see that it prints out our dictionary of key value pairs, comma separated. Should I remove the comma, it's unhappy. One other thing that we can do that's just worth noting is if I did keep the assign the value hello world to the variable sentence, I could actually come down here and, set sentence as a valid value, and that would just assign hello world to number of eggs. So once again, if we went and printed that out, we can see that it now says hello world. Not that that makes any sense, but that's not the point of the example. We just want to see that, okay, this is actually why a variable could be useful. I didn't have to write out hello world again. Now that's an object. The next one after the object is the array, and I'm going to create a variable called example array and set that equal to, and where an object used the curly parentheses and our method takes arguments within a circular parentheses, arrays use the square parentheses, and arrays are essentially a list of items. Now, you could kind of say that this is also a list of items, but it makes more sense to think of it as like a dictionary of key value pairs. The difference between an object and an array is that we don't have the key to associate with a value inside of an array except for the index. So here I could have an array of numbers where each value is comma separated. If I have a whole lot of spaced values, that's not going to be happy, so you have to make sure that they're comma separated, and then you can have these spaces between them. And essentially it just stores a list of information. So the first entry is a 1, the second entry is a 5, and if I went ahead and consoled out example array, that would now show up down here. We can see we have the square parentheses and we have all of our values printing out. Now, one thing to note about the arrays is that each value is obviously at a unique index. However, the common mistake people make is thinking that JavaScript uses a 1 indexing system. It's actually a 0th indexing system. So the first entry is always at the 0th index. So the second entry is at the first index. So in this case just here, this is the 0th index, this is the first, this is the second, this is the third, this is the fourth, this is the fifth, this is the 6th index. Now that doesn't really matter because obviously we can print out values, but later when we learn how to modify and update these different things, we will see the importance of understanding the indexing system, and that will hopefully become a bit more clear to you. But all of these are just different ways that you can store and save data in JavaScript to either later manipulate it or retrieve it, and also just have, clear, clean, concise code that makes sense to everybody who's looking at it. Now, as with any data type, I can assign it to a variable. So I could even assign my Boolean values to a statement. I could have one that says is true is equal to true. Now that's kind of doesn't make any sense, but the point is that we can assign any data type value to a variable. Alright, so that's a lot of information to cover. We're going to do a quick recap of what we've learned so far before we move on again. If we come into the JavaScript notes, we first saw how we can install JavaScript on our computer, and inside of JavaScript, the first thing we really covered is variables and declarations, specifically with the keywords or the declarations const and let. Const is used to initialize a variable where we can guarantee that the value of the variable will never change, and let is used to initialize a variable when the value is likely to change. We also learned that for naming variables, we can use camel case or snake case like so, and it works pretty simply by defining a variable and assigning it equal to a valid data type. Here we initialize the variable a and we assign the number 4 to a. Now as for the data types we've looked at so far, there are a few of them. We've covered the number, the string for sentences, the Boolean, which represents truthy values, either true or false. We've covered null very briefly, which just is the absence of a value, and undefined, which is also the absence of a value, but not because a value has yet to be assigned. We've also touched on objects, which are similar to dictionaries and they contain key value pairs. For example, here we have a dictionary with two key value pairs. We have a name John and an age 30, and we have an array, which is just a list of values that are comma separated, where every value is a valid data type. Up next on our list of things to cover is functions, which is a subtype of an object that can be invoked or called. Now, the way that I like to think about functions is as if I had a little helper robot where you can teach this robot to do a specific task like picking up toys. Once you've taught it, you don't need to explain how to do it again. You just say pick up toys and the robot knows exactly how to do it. That's basically how functions work in JavaScript. It's like a mini program or a set of instructions that we write once and can use it many times. It could be as simple as adding two numbers or do super complicated stuff like sending a message to a friend. And with that all said, let's take a closer look. The last one we're going to talk about is the function. Now, the function is similar in nature to the log just here. The log is known as a method. Methods and functions are very similar, where a method is just a function defined within a class, and we will cover classes later, so don't really worry about that distinguishing point just there. The point is that a function works by using the function declaration, just like we've used these other declarations just up here. The next thing, after we've declared that we're about to initialize a function, we give it a name. So we could call it my new function. Now, I know so far I've used the snake case, and you could continue to use the snake case just here, but I'm going to be confusing. Always been the practice for me that functions use camel case. So that means that the first word is lowercase, and then the first letter of every sequential word is uppercase. So my first function. And then the next thing that comes after that is the circular parentheses that we see just up here. The circular parentheses are where we can receive what's known as parameters or arguments. And then we finish up our function with the curly parentheses that we then open up onto a new line. Now, this is how we would define any function. There is one modern way that we'll learn much later in the course, but this is, the way that I still do it to this day. And in here, we could, use a comment to describe what this function does. So I want it to output the value of is true. Now, functions are absolutely brilliant because they allow us to write code that only gets executed when the function is called or invoked. So just writing the code between the opening and closing circular parentheses, let's say, for example, I move this Console.log in here. Now when we rerun our output, so I re-execute that, we can see that nothing printed to our console, nothing logged to our console. Even though we have this Console.log right here, it still didn't print to our output. And that's because at no point did we invoke the function. Now let's say we go back to how we had it before, and for a second, let's just write Console.log and not use the circular parentheses. If we run that again, we can see that nothing happens. And that's because the circular parentheses are how we invoke a method or function. So just like in here, I had example array. If I move it back into our function, if we go my first function just here, that's not actually going to do anything. If I execute the code, we get nothing. However, if I now use the circular parentheses to invoke it, that's going to call the function, and when we go through our list of instructions and we hit this code line, our JavaScript runtime is going to execute it, and we're going to Console.log example array. So that's pretty cool. We can actually get very clever about the things that we do in here. For example, we could Console.log the console itself. This is totally irrelevant to anything we need to know, but it's still kind of interesting. And we can see that our console is actually an object. So it's just an object, and within it, it has log, which is a function. It also has a bunch of other functions that we could look into. But this is just another example of how interesting the Console.log can be, because it allows us to really inspect and understand things. Equally, what we could actually do is just Console.log my first function. We're not going to call it, so we don't add these circular parentheses at the end. And if we now go ahead and invoke that, we can see that JavaScript is going to tell us it's a function. It gets more complicated than that, and there's more that we can do, but that's a pretty good knowledge for the second about how functions work. The last thing we're quickly going to touch on in a function is the arguments and the inputs. In here, if I named an argument called value or a parameter called value, and I could have another one called second value, they're comma separated. What I could do when I call my first function is I can now pass in the values. So there I pass in 3 and 5. Now if I once again execute the code, will anything different happen? Absolutely not, because we're still consoling console. Let's actually just go back to consoling the example array. However, what we can do within our function is we can now access these arguments, and we could console value times second value. Now what we would expect this to do is when we call the function, we pass in 3 as the first value and 5 as the second value. The order of these arguments have to line up. And now we're going to evaluate the product or multiplication of those two numbers. So 3 and 5, that makes 15. And then we're going to log it to the console. So we would expect to see 15 show up. And it absolutely does. The benefit of doing this is that we could use this code multiple times and we could say 6, 7, 4, and 9. And the code is suddenly very modular. We don't have to rewrite out this body of logic multiple times. We can just call the function repeatedly and output all of these different values, do all these different computations. So the main reason we have a function is to group different related bodies of logic. So in here, I would be better to name this multiply numbers. And that would be a more appropriate function name because it describes the behavior. And we could leave a comment there at the top that just says multiplies two numbers. Now the one last thing is we can actually reassign new functions. So I'm just going back to how it was before just to demonstrate one last concept. Just like up here we've named it my first function, we could actually assign this function to a variable because it's a valid data type and call it multiply two numbers is equal to my first function. And now we could call the my first function. This is kind of a weird thing to do and you maybe wouldn't do this in legitimate code. And it has the same output. So the point is that because my first function is a valid data type, it's a valid value, we can assign it to a variable and then refer to that new variable later. So now that we're pretty familiar with all of the data types, the next thing we're going to quickly touch on is operators. Now, we've come across two operators so far in JavaScript. The first one is the assignment operator. This is just the equals right here. And that's basically just telling JavaScript to take this first value and assign it to this variable. We've seen a couple of ways that we can use that. The next one that we've come across so far is the multiplication operator. That's just how you would do times in Google. For example, if I come over to Google and go 6 or 4 times 8, 32, it's going to evaluate that operation for us. And so you might be able to anticipate that we could actually modify this to a plus. Plus is going to obviously add two numbers. Minus is going to subtract two numbers. Division is the slash. It's kind of like the fraction is going to divide two numbers. And the other weird one is the modulus. Now the modulus of two numbers is the remainder. So that's just going to tell us how much is left over. So 3 and 5, the remainder is 3. 4 and 6, the remainder is 4. 7 and 5, the remainder is 2. How much is left over when we do that? Was I right? 3, 4, and 2. Look at me go. So those are some numerical operators. And once again, these are all covered in the notes. So it's just for familiarity's sake. The next ones that we're going to look at are the comparison operators. So just like above, we looked at the Boolean values. This could also be false. In here, we can use a double equal sign to check the equality. It's got a soft equality, so it's saying is value equal to the second value. Now what we couldn't do is say value equal to second value. That's going to be confusing because that's the assignment and we can't assign to the value. We have to say is the value equal the comparison operator, the double equal sign, the second value. So in this case we would expect 3 is not equal to 5. Let's just change this to a 6 so that it does come out true. And what this evaluates to is a Boolean output. So this is either going to be true or it's going to be false. So now if we rerun our code, we can see that the output is false, true, or false. Now there is also what's known as a strict equality sign, and this also checks the type equality. So it doesn't coerce the types to match. And the reason this would be interesting is because if I make this the string 6, you know, as a human we can interpret that 6 is equal to 6, but because the data types are different, if we use the soft equals, it's going to still say true because it can kind of figure out that they're the same thing. But if we put for a hard equality, the strict equality, and say, is it really equivalent, we use the triple equal sign, it's now going to say false because it's also going to check the data type. The other one that's good to know is the not equal to. So this is basically saying is value, it's the inverse of the original equals checker. So if we run that, it's now the inverted Boolean thing because it says is not equal to the second value. And once again, you can do this with the strict equality as well, so you can have the double equals, and that's going to be a strict equality. The next kind of operators are the logical operators. So logical operators, there's 3 of them that we need to know about. If you're familiar with electrical engineering, it's basically logic gates. We have an AND condition, which means that condition 1 and condition 2 are both true. We also have an OR condition, which means that one condition or the other condition is true. And then we have a logical NOT condition, which basically means if not this condition is the case, which is kind of just inversing it. So if the opposite of what would normally be the Boolean outcome. So to summarize that, we have the AND condition, which is AND. We have the OR condition, which is the double vertical bars, and that's the OR. And then we have the NOT condition, which is with the exclamation mark. And we're going to demonstrate them here. So let's say let condition 1 equal to truth. It's a truthy value. And let's say we have let condition 2 equal to false. So we could console.log condition 1 and condition 2. And in this case, we would just expect it to print the output values of each of them. So here we can see we get true and false. We've comma separated the values, so that's how we print out numerous things within a console.log. Now, if we wanted to trial out one of these commands or one of these logical operators, we could exchange this comma for that logical operator. Now this has changed to console.log condition 1 and condition 2. And so if condition 1 is true and condition 2 is true, then we will print true. If one or the other is false, then we will print false. And if both of them are false, we would print false. So in this case, we would expect it to print false. And that's exactly what we get, this bottom one just here. I'm going to comment those out because we don't want them to print for the minute. And then if we tried the OR condition, so that's the double vertical bars, if one condition or the other condition is true, then we would expect the overall output to be true. And in that case, we get true because condition 1 is true. Now the last one is the NOT condition, and that works slightly differently. Basically, you just plonk a big old exclamation mark in front of the condition that you're trying to evaluate, and that's going to inverse it. So condition 1 is true, we're going to get the NOT of it, or the opposite, and so it's now going to be false. So if we just print that, that's going to be false, and you can work with all different combinations of these logical operators. Now the one other thing that I would mention is that some values kind of default to false. For example, if I put 0, that is a falsy value. So if I do not 0, we would expect that to output true, and it does. So that's not really too critical, but it's just worth knowing. But you know, the same as for an empty string. It's kind of like, is this a value? Is it closer to being a true value, or is it closer to being a false value? You know, we're going to invert what it would normally be. So that also comes out as true because this alone would be false. But that's not super important. It's just worth knowing that some values will occupy a falsy state. Now the last thing we can do with operators and data types is we can actually check them. So here what I can do is use the type of, it's a reserved keyword in JavaScript, to check the type of whatever comes after it. So in this case, I could check the type of the string, and it's going to tell us that it's a string. If I check the type of my function up here, we can see that that's a function, and likewise you could go through and do this process with all of them. That's just kind of fun to know. and that is once again in the companion guide. We can see that, interestingly, example array comes out as an object, and there's a good reason for that, which we will touch on later, but you can refer to it as an array. However, JavaScript understands it as a more abstract type of object. Anywho, that's pretty much it for the fundamental JavaScript syntax, including variables, data types, and operators. We kind of jumped ahead and included a bit of functions just because it is a data type. The next thing we're going to look at is the control flow through conditional statements and loops. Now, so far, everything in this code that we've written pretty much just executes, except for the function, which only gets called when we invoke it. But what if we wanted to have some code that conditionally executed? So it didn't necessarily always go, but it did depending on the value or state of something. Well, we can totally do that using an if or if-else block. They're actually super simple. All we have to do is say if, and then we could literally pass in our condition inside of these circular parentheses. And likewise with a function, instead of just having the function, we still use the curly parentheses in here to encapsulate our if or conditional block of logic. So just to summarize, it's going to check if this condition is true, then execute this block of code, and if it's false, then skip over it. So in here I could throw in a Console.log that says, "Hi mom," and then I could also include just like that, pretty straightforward. And if we execute this code, we can see that because the condition 1 was true, that code block was indeed executed. And I'm going to comment that out for the second. Now, if I were to swap out that condition, see what the code does, make sure I save the file, we can see now it's no longer executing because the condition is false, and it's like, all right, well, I'm not going to execute this code yet. So that's pretty cool. Likewise, we can actually use our operators from before. So I could check for multiple things. I could say condition 1 and condition 2. In this case, we would not expect it to run because the combination of both of them still evaluates to false because it expects both of them to be true. However, if we change this to a true value, then that is going to now run. Very cool. We can take this a step further and have an else block chained onto the end of it. The else block is cool because we can say Console.log. The value was false, so here we are. So we've checked if the condition is true. If it's true, we'll print "Hi mom." If it's false, we'll print the other statement. And so if I change this now to false, we would expect the other condition to run. So this is just, once again, a really brilliant way that we can have some conditional code that doesn't necessarily always get executed, or maybe it's dependent on a state of something earlier up in our code. There is still one layer extra that we can just add on this. We can also have an else if block in the middle, and so every block just has the curly parentheses around it. However, a subsequent else still needs a second condition to check. So we could say if condition 1 and condition 2 print Console.log mom. This is going to fail because both of them aren't true. Then we could just say if condition 1 or condition 2, that's pretty cool. We can Console.log one condition of the 2 was true. And otherwise down here we could print out the same, and so in this case we would expect the middle block to run because only one of the 2 was false. Now there is a bit of a science to how you want to order your conditions, but it just takes a bit of thinking about, and it's something that once again we will get with more practice later on in the course. Now the second type of conditional logic that we have in JavaScript is loops. Now the purpose of a loop in JavaScript is to be able to write a body of code once and execute it numerous times. It could be thousands of times, but it's typically until a condition is met. For example, until we've executed it for every element in the array. And the first loop that we're going to look at is the while loop. And for the loop, I brought down the example array. And so we're just going to initialize a while loop by saying while. In here we have a condition, and then we use the curly parentheses to contain a block of logic. And essentially how this works is it executes the body of code while the condition remains true. If at the end of an execution the condition is still true, it will execute it again. So for example, I could define a counting variable. Typically for counting variables, they define them as either an I, j, or k. And I could say equal to 0. Then I could define a length variable, which is equal to the example array dot length, where the dot length is a special parameter of the example array that tells me how many elements are in the array. Not necessarily the maximum index, but the number of entries in the array. We could actually go ahead and Console.log the length quickly, just as a little thought experiment. So what I'm going to do is comment out that code right there, and let's just execute the code so we can see there's 12 elements in our array. Now if I come back in here, we have our while block. We could say while I is less than the length, where the lesser than is, an operator in the same way that we have the assignment operator. We could also have greater than, we could have greater than and equal to, we could have lesser than and equal to. But in this case, only lesser than makes any sense, because if the counter is greater than any particular index in the array, it's going to be trying to access values out here, which just doesn't make any sense for us at all, and will break our computer. Equally, if we didn't have the condition and we kept looping over all of the values, then we would just get to a position where we eventually try to access an entry out here and it breaks regardless, and that's all good. So what we can do now that we have our condition, only execute this loop block while this is true, we could add in a Console.log value was true, and then what we could do is actually just put on I. So if I go ahead and run this code, I'm actually going to guess that this is going to break my computer, and we can see that it's executing and it's continuing to execute. And the reason it keeps continuing to execute is because I is always 0 and it's less than 12. So that is a truthy condition, which means that we execute this code block. However, now what I could do is at the end of every loop, I could say I is equal to the previous value of I, and then I could add 1 onto that. So now after I Console.log the value of I, it's going to say, all right, reassign a new value to I that's equal to the previous value plus 1. Now when I run the code, we can see that it very quickly executed, and we started off with 0, moved through 11, and it was happy days. There's actually a shorthand syntax for this. If we just go I++, that will increment it by 1 every time, and I will decrement it by 1 every time. So we could do I++ just like that. And that's pretty much how a while loop would work. What I could do, and this is a syntax we'll cover more later, so don't worry if it's a bit new, is we could also in here access the value at the index. So we could say example array, and then we use the square parentheses to access a value at the index I. So when I is 3, we access the value at the third index. So this is the 0th index, the first index, the second index, and the third index. So that would be 9. And that's going to go through every single index in the array and Console.log the value. If we run that once more, we now see the index and the associated value. If we look at the array, we can see the 0th index was a 1 and the 11th index was equal to 2,342. So that's pretty cool. Now, where we have a while loop before, I've commented ours out, we can also have a for loop, and it works in a similar way, except instead of just having one argument passed in to the while loop, we now have 3. The first one we have to pass in is a definition of the counting variable and what it's initialized to. So we start off j and we set it equal to 0. It's the 0th index. That's where most arrays start, the 0th index. The second one is the condition. So we can still say j is less than length. The same condition that we had just up here, except it's j this time. And then once again, a semicolon to separate the last condition, which is the incrementer. So we're going to say j++ or j is equal to j plus 1. So that would just increment the value of j by 1 every time we complete a loop. Now it's got all the same parts as the while loop, however it's just written in one nice syntax, and they can have slightly different functionalities depending on what you're trying to do. The for loop is more traditionally for going over, one index after another for a definitive length. Now I could go ahead and copy and paste the exact same statement in here. It's a nice statement to demonstrate the concept. And so what's going to happen is the for loop is going to initialize j to 0, execute the for loop over and over until we hit the condition, so until j is no longer smaller than length. And every time we successfully complete it, we're going to increment j by 1. And the reason that's not happy is because we just have to remember to update the values in our console to use j instead of I for our new loop. And so this is going to go through every value and do the same thing as our while loop did just before. For loops are extremely common, and the only other thing that's worth knowing about them is that if you ever wanted to skip a section, for example, I could say if j remainder 2 is equal to 0, so this is one way to check if the index or the value of j is equal. And inside of here, what I could do is I could just say continue. Now continue is a reserved keyword that basically says, all right, just skip this loop. So if the index value of j is equal, it's going to skip and not console out the value. So here we can see we only printed out odd indexes of our array. Likewise, what we can do is use the other keyword that is commonly found. It's break, and break basically means if a condition is met, end the loop early, so basically kill it. So the very first index was technically even, it was 0, and so it ended it immediately. Equally, if I could say j is equal to 6, kill the loop early, and it would break it as soon as we hit to 6. So those are just two interesting keywords, the continue and the break one, worth knowing, and they work with the while loop as well. And just like that, we have covered control flow through conditional statements and loops. Now we're just going to finish up with some more function stuff that's good to know, and that will be our foundations completed. So we created this function earlier where it takes some arguments and we just console some values. We saw that we can reassign a function to a new name, and then we can call it and pass in the arguments, and we use the circular parentheses to invoke the function. But that's definitely not everything that a function can do. So if we come down the bottom, let's start making some new functions. So here I'm going to make one called function add strings. Now this is going to take string 1 as an argument and string 2 as an argument. Now in here what we could do is we could just say Console.log string 1 and string 2 like that, and that's going to print out the two strings. So now that we've defined it, we could go ahead and invoke it. Let me just comment out for block above so that that doesn't execute. We can now call add strings, pass in 1, hello as the first one, and mum as the second one. Now see if you can anticipate what this is going to output when it runs, and even better, maybe run it yourself. When we run that, we can see we get hello mum with the space in between because we comma separated them. Now something that we could do to make this a bit more interesting is we could actually do what's known as string concatenation, to add one string to another, or to concatenate one to the end of the first. And in this case, all we do is we use the plus symbol. Just like we would add two numbers, we can add two strings, and that will combine them into one overall string. So in here we can see if I print that, it prints out the combination of the two words. It's missing a space in between, so what I would then do is concatenate a space in the middle, and if I rerun that, that now says hello mum. Now we could make this code a little bit nicer. Up here what we could do is we could say let concat string equal to that value, and now we could just console.log concat string, and that's going to do the exact same thing. It just looks a bit more interpretable. Now what we could do to make this function a little bit robust is we could add a condition in, and we could say if not string 1 or not string 2, which basically says if the user doesn't pass in string 1 or it doesn't pass in string 2, so if they don't exist, then we can use the keyword return. Now this is a really interesting keyword, and it basically, when a function hits the top level return, it exits the function. It's equivalent to breaking a loop. And in this case, when I execute our code, string doesn't exist. That's supposed to be string 2, so let's run that again. we can see that we have both strings, so this block doesn't get executed, and we still console.log this value. But the reason the condition could be good is because if we only passed in one value, this code isn't going to work. There's not going to be a second string to add on to the first. And so now if we run that again, we can see that the code is not executed, and we could even print out a message that says, you are missing an input, just like that. So now we would expect to print you are missing an input, which we do. So that's pretty cool. Something that we could do as an alternative to this little, it's known as a guard clause, is we can add default values to our strings. So I could add an equals and default 1. I don't know, you could probably come up with something more creative. And we could add a default 2. And now if the value is not passed in as an argument when we actually invoke the function, it will assume the default value. So in this case, see if you can guess what is going to print. I would anticipate it's going to be string 1 because we're passing in string 1. However, there's no input in the place of string 2, so it will assume hello default 2, which is exactly what we get. Now the other thing that functions are really good for is returning something. Earlier we came across the keyword return, and it exited the function, and we had nothing after it. It was just blank space after the function. However, we can actually return something from the function, and we can think of this as you know, it's literally as simple as you go to the shops and you return with an item. The product of you going to the shops returns the milk to the fridge or something like that. So let's say I wanted to create a new variable or have the function actually return the product of the two strings. Instead of just printing, I wanted it to actually give me that value back. I could say let new string equal to add strings. And as I said earlier, if I return the value, instead of this just calling and invoking the function, the returned value will actually take the place of the function. So essentially it's kind of like what gets left behind. Concat string gets left behind at the end of the function. So we'll still console.log concat string, but now the concat string will be assigned to new string, and I could actually console.log a sentence that says the new string is, and then have new string, just like that. And if we execute this code, we can see that we actually assigned something to new string. So something was left behind as the remnants from the function, which is whatever gets returned out, and that is something that we can assign to the new thing. If I don't include that line, let's say I comment it out, new string is going to be undefined. So we'll still console.log this line just in here. However, new string is undefined because we didn't return anything from the function. We didn't leave anything behind after the function was executed, is a good way to think about it. So functions can be super useful because we can see just here how I can now add strings with a function that I've created over and over, and it will return me new strings. So if you ever have a system of code, let's say you were writing a compound interest calculator, or you were fetching some data, or you were analyzing an image, you could write a function for it, pass in a whole lot of stuff. The function can get executed whenever it's invoked, and it can return an output. And this is a brilliant practice for writing code in general, as having functional components. And as much as I've just been slamming stuff in a JavaScript document right here, a really nice, neat way to do it is to break down your code into the different functionalities and then invoke them in an order that makes sense and when necessary. That's definitely not the end of functions. We will come back to it more, but that's a great overview for now, and learning how we can use them to structure our code. Anywho, congratulations on finishing Chapter 2, learning the basics of JavaScript. And that, my friends, is the end of Chapter 2. It's by no means the end of the JavaScript course. If you would like to experience another 8 chapters in developing your JavaScript mastery and becoming a JavaScript wizard, get access to loads of amazing lessons, plenty of practice questions, and not only that, 5 absolutely phenomenal JavaScript projects, then I'd recommend checking out the JavaScript course. The link is in the bio down below. Once again, thank you so much for watching the video. I hope it's helped you feel confident and comfortable inside of your JavaScript editor, and I'll catch you guys in the next video. Peace. Learning to code? If so, be sure to check out the Learn to Code roadmap or dive straight in with these videos. That's a good one.